Even after cutting stuff out, I still had kids take a full 45 minutes with it. Zoom, zoom. Callister, you need to go talk to the guidance office. Why are you signed up for PreCalc again?
Again?
Yes.
This is a legacy then. I had no idea.
Like, nah, dude. You've been in here for a year. Go away. And when you finish this, I want some of you to contemplate that today is West River Math Contest, and there are some of you that should be there, and I'm not mad, but I am disappointed. Oh, there were a couple that I was going to make them do it. Like, I ain't putting in any of your test grades until you go, kind of make them. But kids these days. exist.
Yes, they do exist.
And these take a little more. Who's still going? 2? 3?
Yeah.
There. I hope. Okay. If I'm going to graph conic section, I need to know what kind it is. I determine what kind it is, at least until we learn our trig identities, by looking at it and saying what kind of critter has two squared terms, but one of them's negative. Hyperbola. Okay. If it's a hyperbola, I'm going to treat it as such. I will take my x stuff together. 4x squared plus 24x minus y squared plus 4y is 28. Factor out so I can remove an a value and say 4 by x squared plus 6x, leave a space to complete. Take out a negative 1, y squared minus 4y is 28. Be careful with your signs. I complete the square. Half of 6 is 3. 3 squared is 9. I didn't really add 9. I added 36. Half of negative 4 is negative 2. Negative 2 squared is 4, but I didn't really add 4. I subtracted 4. And then the quantity, x plus 3 squared as a perfect square trinomial. The quantity, y minus 2 squared as a perfect squared trinomial. Now over there, I get 60. When I divide by that 60, these will reduce down to 15 and 60 respectively. So, now that I'm here to graph and label, you got to know, where's the center? Come on, you sound like first hour. You're hurting my feelings.
Negative 3, 2.
Hey, there we go. Which way is it going to open? And how do I know?
To the side.
This way. I don't know what the words are, but I know this way. Right? Horizontally. Okay, along the x-axis. So I'm going to put a center at negative 3, 2. When I go to make my asymptotes, remember, a squared over b squared or b squared over a squared really is a question of y over x, rise over run. So in this case, you get square root of 60 over square root of 15. How many of you took the long route to Walmart again? Versus how many of us said 60 over 15 is 4, square root of 4 is 2? I hope we can do that now. Okay, so I got a slope of 2. And then I'm going to A in those directions, square root of 15, so my vertices are kind of ugly. That's okay. Vertex at negative 3 plus root of 15, 2. Vertex at negative 3 minus root of 15, 2. I've got my asymptotes. I've got my vertices. I have the ability to make z hyperbola. And if I have the hyperbola, I'm almost done. What's missing? Foci. And I actually need to write what those asymptotes are. Okay, the foci, c is square root of a squared plus b squared this time. So 5 root of 3. So I'm going to come all the way out there and all the way out there for foci, negative 3 plus 5 root of 3, 2. Focus at negative 3 minus 5 root of 3, 2. And then next to it somewhere, I've got to write my asymptotes. Y minus 2 is plus or minus 2 by x plus 3. Those are parentheses, I swear. Notice that you're not going to be able to graph the thing without getting the correct equation. So what we're going to do is 1 for your work to even get to the equation. Because naturally, if you screw up there, this whole thing is just right down the crapper. Okay? But then from there, the process. Do you have this in the correct order and this opening in the correct direction? Do you have the correct center? And I'm going to say the correct center and asymptotes, because that's what informs the shape of your hyperbola. If you had your a squared b squared in the correct spot, then you should have had the correct vertices and the correct, now that I think about it, no, Frank, stop. There you go. If you've got all that in the correct spot, you should have had the correct vertices and the correct foci. But then I'm also going to say one for, is your hyperbola of the correct shape? So you can't just make generic slope of plus or minus 1 and label. Does it open the correct direction? Does it have a slope of about 2? Is it proportional? Did you label everything? Even if you put it off to the side, remember that graph gets pretty cluttered. So kind of a 1 for the work, 1 for the order and format of the equation, 3 for the graph and the right points, if you want to wiggle it that way. There's a thing. What's the thing?
Would you be able to pick one of my sophomores during Spartan time? Because I have NWEA testing.
Oh, yes. Yep.
Okay, I will let
Yeah.
him know that. Thank you very much.
Wait, which one?
That one.
All right.
Thank you.
That one.
Harmless.
I mean, they're not a bad kid, but a lot of life has happened and a lot of choices have been made because of that. So, all right. The homework. The only question that I had was 68. Well, I take that back. I had 1 or 2 kids just double check their complete the square, just making sure that the mechanics of it are correct. But the only conceptual question that I had was 68. Can you find the center of that thing from that graph?
Yes.
You know which way it's opening, so you know which one goes first, X or Y. You can find A squared by determining where your vertices are. You got all of that. Y'all, if you know all of that, you got y minus 0 squared. Yeah, I know that's just y squared. You have x plus 3 squared. You know that's 10. And you don't know this? Remember, all this time, we seem to forget once we get bogged down in all of this algebraic manipulation that an x and a y is always in my equation because that's a coordinate on that equation. So put 1 there and negative 2 root of 5 there. Solve. Plug in what you know, solve for what you don't. Okay? And I've included a couple like that because of that. So, review. Here we go. 1 potato, 2. You know what? 1, 2, 3. Screw it. You do it. Here. 2 for you. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Everyone got one? Okay, before we go diving into the weeds here, a couple of things. A, I double checked with Mr. Spear about which things I was pretty sure you didn't need yet. So our schedule is locked in now. We're going to do quiz today, 4 days of chapter 6, quiz next Monday, 4 days of chapter 10, quiz the following Monday. Okay. So Monday quizzes, just because of where we land. In 6.2, normally that's a 2-day thing. I cut out all of our inverses. You don't really need those until like Calc 2. Same with in 6.3. We'll just get as far as we get, and we probably won't get to our irreducible quadratic denominators. That's fine. In chapter 10, we'll be able to hit sections 1, 2, and 3 hard enough. And for 5, I'll just show you the probability formula and call it good. That gives us a day of review on the 24th in class. You should be reviewing before that. Now, I was going to have it printed for today, but I need to collect your opinion. You've had a couple of weeks to think about this. Option 1. The final as intended, as it's been for years, because this is an everyday 90-minute block class, you are supposed to be in here on block 2 on that Wednesday and block 3 on that Thursday. Your final is supposed to be 2 parts, and that's what it has traditionally been. 40 questions, multiple choice, covers a whole semester. It is proportional, so if we spent a lot of time in a particular unit, there's a lot of that stuff. If there's not much time in a unit, there's not much of that stuff. But either way, it's not going to be open notes, because I've got kids who are going to be wiggling their finals around, maybe taking one early, taking one later. I've got some kids who like to come in that they just skip out on Wednesday so they can study up for their other finals, and then they come to back on Thursday instead, whatever it may be. What I'm going to do is say your review, which looks just like the final, just like we do for our review and quiz right now, and whatever you can write on it. So you get to tell yourself how to do the final. Okay? Your review and whatever you can fit on it. That's it. That's all you get. So it would be a bad idea to not review for your final. Option 1, 2 days, 20 apiece, and on each day you only get that portion of the review, because you got to turn it in with your final to receive credit. If you do not turn in your review with all your stuff written with your final, 0 for that portion of the final. Or 1 day, 20 questions cherry picked for the most important concepts, and still you get the review. So it's whether I print the review as one big lump or I print it as sections A and B. Okay, you got to decide. And me and SurveyMonkey were having an argument about what my password is. So what you're going to do, you flip this over. The test looks the same. You notice question 6 isn't there. It's a blank because, well, there's a lot of stuff, a lot of moving parts on here. There's not nearly enough time to do the entire test. So in that blank space on your test, we're going to go manual ballots. You're just going to write 1 day or 2 days. Majority rule. Okay? 1 day or 2 days. With 1 day final, less testing, but less margin of error. If you're aiming for that grade replacement, the whole Good Samaritan option thing. They can get like, what, 1 wrong, maybe, to get your A. If we go 2 days, it's more testing, it's more stuff, but there's a greater margin of error. You can get like, I think it's 3 wrong. So
Twice as many questions.
Twice as many questions. So it depends. It depends on what you want, and I'm gonna leave it up to the people. Okay? So on your test, at the bottom of the back page, you're just gonna write 1 day or 2 day. Okay? And whatever that is, I'll print out the review as you decide. And tomorrow you can pick that up, and I suggest you start reviewing the next 2 weeks instead of leaving it all for the day before. Hint, hint, front row. So, I don't know what it is. Like all year long, it's been the front row is like the goobers. Like normally the goobers try to hide in the back, but huh. Algebra 2 last semester. Jacob was one of them. Yep. All right. So that's where everything lines up. Oh, and that Wednesday, I haven't written it back there yet, but that Wednesday, block 4 for finals, I will not be here. So no rearranging your finals to do it that day. All right. What kind of critter is this? How do I know? Okay. How many squared terms are there? Do they have the same coefficient? Is one of them negative? In this case, I've got one squared term, so I know it's a parabola. I'll treat it as such. X squared minus 6x, all the not x stuff to the other side. I complete the square. Half of negative 6 is negative 3. Negative 3 squared is 9. By this point, I think we're probably okay with complete the square. It turns out it wasn't that bad. And I add 9 to the other side as well. So I write this as x minus 3, the quantity squared, is, do not leave this as 12y plus 24.
Take out the 12.
Okay, take out the 12. Well, what if that's 12y plus 30? Now what?
Take out 12.
So you still take out the 12 because you have to separate y minus k from the 4p value. So if you're all okay with it, I'm just going to sneak that in here. Y plus 2. All right, so we identified what kind of critter is it. We complete the square, we turn it into the thing. Now, notice the directions, graph and label. It doesn't say what to label. So now that you know what kind of critter is it, what are we labeling? Vertex? Foci? Axis symmetry? Directrix? Ooh, I heard it. You need at least 2 points, one on either side, so you can show the stretch or compression to it. I would use points that are nice to find. Remember our perfect square step, something that's divisible by whatever it may be. Also, notice that you just got plain grid over here. That plain grid is because you graph it however you're going to graph it, but make sure it's to scale. Here's what I mean. No, you cannot just do this and then just start tossing points on there. That is not drawn to scale. That is not proportional. I have it like this so that you can decide, do you want to put your coordinate axes on there and then go from there? Do you want to just put your parabola in the middle and label as you're going? I'm letting you decide. Okay. Now what we had been doing for most of the chapter is go find your vertex. Which way does it open? Where's the vertex? Is it 3, negative 2, or is it negative 2, 3?
3, negative 2.
Okay. So I got a vertex at 3, negative 2. Which way am I going? How do I know?
Wait.
X is squared, so it's vertical parabola. I know that's kind of annoying that when you switch to ellipses and hyperbolas, it's the other way around. X is squared, it's vertical parabola, and 4p is positive. Okay, you know what? I want to make the rest of the parabola before I go labeling other stuff. Remember your stretch or compression. 4p is 1 over a. So A is 1 over 4p, or 1/12. If I'm going to go making more points to this thing, I want to pick perfect squares that are divisible by 12. 36. Normally, I would go over 6 and up 36. But now, from that vertex, I can go over 6 and up 3. So over 1, 2, 3, 4, 5, 6, up 3. And tell me what it is. 9, 1. Back 1, 2, 3, 4, 5, 6, up 3. Tell me what it is. Negative 3, 1. Now, that's all I need to see from you. If you want to put more on there to make a better graph, I'm okay with it. 1/12, 4/12, 9/12, 25, no, 16/12, 25/12. So you can do that to get some better points. 1/3, 3/4, 1 1/3, 2 1/12. I do that because otherwise my graph sucks. It's a big piece of paper. Okay, so I've got the parabola, but what are the other relevant features of it? We said axis symmetry. What?
3. X.
X equals 3. Remember, an axis symmetry is a line. Lines have equations. But where is it? Not C. P. This is 4p. If 4p is 12, then p is 3, and I'm going to p in both directions. I'm going to p in that direction. I'm going to get a focus at 3, 1. I'm going to p in that direction and get a directrix. Y equals, because it's a horizontal line, -5. Don't just label the point where those two intersect. Notice there's an awful lot of stuff going on here, like an axis of symmetry, a vertex, a focus, 2 additional points, your directrix. X and Y are in the correct order. Have your correct 4p value. 1, 2, 3, 4, 5, 6, 7. Completing the square correctly. There's a lot of stuff going on. Okay, these are going to be worth more points because we are doing less questions. Okay, contestant number 2. What kind of critter is it? How do I know? Well, how do I know it's not a circle? Different coefficients. Now, if that was 64 and 64, okay, now it's a circle because when I try to divide, they're going to have the same denominator. What do I do when that happens? I'm going to divide and they're both going to have the same denominator. What should I do instead? Equal r squared, my radius squared. Okay, so I'm going to 64y squared. Nah, ellipses, we usually have x first. I mean, it can go either way, but 25. You okay if I factor on the fly? Take out 25 from both my x squared and x terms. Take out 64 from both my y squared and y terms. Half of 10 is 5. 5 squared is 25. Did I really add 25? Nope. Half of 4 is 2. 2 squared is 4. Did I really add 4? Nope. Ooh, that's a big mamma jamma. That's x plus 5, the quantity squared. That's y plus 2, the quantity squared. And so what's 64 for 1600? So when I divide by 1600, 25 over 1600, 64 over 1600. They happen to equal each other. And that is pretty common when someone creates a problem backwards, that happens. Don't assume it, but it's fairly common. And what I mean by does it backwards, I actually start these with the graph. I make a graph the way I want the graph to look. And then I work my way backwards to the equation, and then I decomplete the square to get the equation. Okay, so I got an equation. I'll come over here and get rid of this so I can see what I'm doing. Where's my center? Ruh-roh, Raggy. If my center's at negative 5, 2, I'm going to just go put center. Oh, didn't hear that part. Is this thing stretched vertically or horizontally? How do I know? The larger denominator is a squared with an ellipse. So we're going to A in both directions along the x-axis. I'm going 1, 2, 3, 4, 5, 6, 7, slightly off-road. And I'll have to write it up here because I don't know how big my potato is going to be. 3, negative 2, and I'll just do this. Okay, 1, 2, 3, 4, 5, 6, 7, 8. I got a vertex way back here at negative 13, negative 2. I A in those directions. I got vertices. What other features? Co-vertices, and we'll B in those directions. So I'll go 1, 2, 3, 4, 5 for a co-vertex at negative 5, 3. Go 1, 2, 3, 4, 5 for a co-vertex at negative 5, negative 7. I will draw my potato. When I draw the potato, y'all, as long as it ain't a diamond and you try to make it curvy, no, bad. Try to make it reasonable. Okay. Okay, it's going to kind of look like a lemon. Okay, mine ain't pretty. I dare you to draw a 3-foot wide circle or ellipse. Okay, cool. I got my center. I got vertices, co-vertices, foci. To find the foci of this dude, square root of what? Minus b squared. 64 minus 25 is 40, 39, so they ain't pretty. I'm just going to have to leave it as square root of 39 as a distance. Or are my dots on my lemon wrong?
No.
You're counting very intently.
Make sure I have them.
Okay. Yeah, the graph was just like one box, not wide enough. Square root of 39 is about how far? This is what I mean by make it proportional. Don't just draw potato label. You got a grid here. Go 6 and change boxes. Okay. 1, 2, 3, 4, 5, 6, and some change. My focus is at negative 5 plus square root of 39, negative 2. Go 1, 2, 3, 4, 5, 6, and some change. A focus at negative 5 minus square root of 39, negative 2. Okay. Try to make it curvy. Okay. I know some of us, not the best artistic skills. throws shade at Chad. But as long as I see that there's a curve there, you got everything labeled. Again, if you don't like having all this stuff on the graph and you'd rather label it off to the side, you still need to have all of these points in the correct spots. You need to have it proportional like this. But I can still do this. I can do that and then list out coordinates off to the side. Okay? I know some of us get really mad if our graph is cluttered up like that. But you have to make sure it's still proportional. It's still the right number of boxes. Okay, we saw a parabola. We saw an ellipse. Take a wild guess. Contestant number 3 is a hyperbola because we've got two squared terms and one of them is negative. Now, if I were to... Which one goes first? Okay, positive. 36x squared minus 72x minus 16y squared minus 64y is 604. The reason I'm writing that and not factoring on the fly is because number one error on this that kids make is when they factor that negative 16 out, especially if they factor on the fly, they miss that's now plus 4y. And you don't want to get got. Okay. Number two most common error that people make on this is when they complete the square. Half of negative 2 is 1, 1 squared is 1. Half of 4 is 2, 2 squared is 4. They just won't write anything on the right side at all. We'll just leave it as 604. Make sure that you're writing stuff over there. And then they go do this. The number 3 most common error.
Wait, that's fine.
Because you have to ask yourself that question. Did I really add 1? Oh. Did I really add 4? Nope. And that's why that sign and these parentheses and all this they're important. Look at how many times you're completing the square now. Turns out it wasn't that bad. For 3 years, you've been avoiding it like the plague, and it's actually easier. We should stop using that phrase because we've shown that we don't avoid the plague. We just let a million people die. X minus 1, the quantity squared, minus y plus 2, the quantity squared. Okay. So 604, what's that, minus 640, 545, 76, divided by each, should be each, 16 and 36 respectively. Okay. All right, I've got my hyperbola. Hyperbola. Okay, I'm going to get rid of this part so I can go over to my grid. There we go. Where is thy center? Oop. So center 1, negative 2. How do you start this? Like, you can find your vertices first, you can find your asymptotes first. What do you do? Ooh, I literally heard both at the same time. Okay, so vertices or asymptotes, it's kind of your jam. A is 4, B is 6. Positive is my a squared term, not the larger. And if I go for this way, 1, 2, 3, 4, for a vertex, I can write that, 5, negative 2. If I go 4 this way, 1, 2, 3, 4, I get a vertex of, what's that, negative 3, negative 2. How many of us are making the box? Some kids like the box, some kids hate the box. If I go A in those directions and B in these directions, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, I can just kind of connect the dots on my vertical and horizontal spacing to make the box. Some of us like the box, some of us hate the box. Or you go and find your slopes. Okay, but it is A in this direction, B in that direction determines the shape of those asymptotes. And the shape of those asymptotes, if I write it, y plus 2 is plus or minus slope x minus 1. The slope, A over B or B over A, how do I know? Okay, it's more about y over x than it is A's and B's. So 6 over 4 reduces down to 3/2. And I should see if I went from that center up 3 over 2, up 3 back 2, down 3 back 2, over 2. Okay, it does have that slope to it. So whether it's reduced or not. So I've got my asymptotes, I've got my vertices, I'm probably good to make hyperbola. Okay, kind of a wide one. In fact, it might not have been a bad idea to do this by a scale of 2, but oh well. We're good, right? You have to make sure, label the function. Make sure you're labeling everything you're supposed to label. C is found how with these guys. Okay, so 16 plus 36 is 42, 52, 2 root of 13. Which is about how far? This is 52, right? Square root of 52 is just a little past square root of 49, so 7 and some change. So I'll go 1, 2, 3, 4, 5, 6, 7, and some change for a focus at 1 plus 2 root of 13, negative 2. I'll go back this way, 1, 2, 3, 4, 5, 6, 7, and some change for a focus at 1 minus 2 root of 13, negative 2. Make sure you're labeling everything. Do you have your slopes? Do you have your center? Do you have your vertices? Do you have your foci? Does the graph actually look proportional? Did you put them in the right order with an actual minus sign? You know what? Are you putting squared on there? I've got kids who forget that. I've got kids year after year who will just write this. Why is green wrong? This isn't even an equation anymore. It's just an expression. So please make sure that you have all the parts because these are going to be worth a big chunk each. Flip to the back. We got time. Skip to 5. Do you remember what eccentricity is? C over A is how you find it. What is it?
It's like ratio from the.
It's a
How much? How stretched out is it? Okay. It is a ratio between the distance to the focus and the distance to the vertices. And as that ratio in an ellipse goes from 0 to 1, it gets more stretched out. As it goes from 1 to infinity in a hyperbola, it gets more stretched out. Okay, it's how stretched out a thing is. So y'all remember how to do it? We're not going to do that on the tests. I'm going to have you cross out 5 just to save us some time. Okay. Do you remember what tangent lines are all about? Or if I give you features of a graph, can you make the equation?
Yeah.
Okay. First things first. Is this in standard form?
No.
What goes in front? Okay, dividing by -1/4 is the same as multiplying by -4. Is this parabola open up, down, left, or right? X is squared, so it's vertical. 4p value is negative, heads downtown. So, womp. Draw generic parabola, may not be to scale. I've got a vertex at 6, 9, obligatory noise. Focus, how do I find the focus?
On your A value.
Okay, if 4p equals -4, then p is -1. We're going to head downtown, 6, 8. And it tells me that there's a coordinate on this of 10, 5, so write them down. How do I find my tangent line? Distance formula. I think we can do one better than that. How far is it from 6 to 10? How far is it from 8 to 5? Take a wild guess what that line is. 3, 4, 5 triangles. No, it is not. He literally had his eggs scrambled. Okay. Okay. 3, 4, 5 triangle. Or distance formula, I don't care. So here's the real question, what do I do with that?
You go down to the, or you go, oh yeah, you go up.
On the vertex.
Yeah.
The point. To the point.
It depends where. Remember, I can now go 5 north to find my directrix, but this isn't asking. I already know where my directrix is going to be. I'll just go 1 above my vertex. I need to go from the focus to go find that magic point. We didn't even have a name for him. First hour called him Chester. Okay, that magic point is going to get me my line of tangency. Hey, that actually wasn't bad. Okay. And then line between 2 points. Okay. So I go north of my focus, not my vertex, 5 units. So I've got a point at 6, 13. And then, can you make a line between any 2 points? Go find your slope. I see down 8, right 4. So a slope of -2. y2 minus y1 over x2 minus x1.
-2 and then use the points.
Personally, I'm a fan of point slope form. I would say y minus 13 is -2 by x minus 6. I would just pick one of those points and use it. But I'm also going to cross that one out. Okay. The next time you're going to use tangent lines off of conic sections is at the back end of Calc 1. And you will review it again. More so if you don't know how to find a line between any 2 points, what are you doing in my class? And B, there's a number of sophomores in here. Y'all gonna have to do an ACT. Most of that ACT is Algebra 2 and lower. You're gonna have to remember how to do basic math. So, devices over there. Scramble yourselves up.